Assalamualaikum and good afternoon. My name is Muhammad Ridwan bin Muhammad Isa. Today I will present for our project for subject ISP 542 Fundamental of Artificial Intelligence. For our group topic is AI in healthcare, early detection of skin cancer using computer vision. Our lecturer is Dr. Azliza binti Muhammad Ali. So this is our team. The first one is Muhammad Ridwan bin Muhammad Isa. This is me. And the second one is Muhammad Azkar Bashiri bin Muhammad Zaidi. The third one is Zarul Hafiz bin Zainul Abidin. And the last one is Muhammad Aiman bin Zulkifli. Table of content, we have 5. The first one is introduction of artificial intelligence. The second one is defining AI. Third is difference between weak and strong AI. Fourth is real world problem and impact. And the last one is representation model and decision tree. Defining of AI. AI enable computer to perform tasks that normally require human intelligence. AI can learn from data, recognize pattern, make decision, and interpret image. In healthcare, AI help analyze medical record, image, and diagnose result. AI can improve diagnosis, treatment, health research, and public health decision making. AI must be used ethically, safely, and responsibly. AI is used for skin cancer detection. Machine learning and computer vision help classify skin lesion as low risk, medium, or high risk. Evaluation of AI in healthcare. AI in healthcare begin with rule-based expert system. Early system like MySyn help doctor diagnose infection and suggest treatment. AI later developed into machine learning which learn pattern from medical data. Machine learning is used to analyze patient record, symptom, lab result, and medical image. Deep learning has improved AI in medical imaging, especially for skin care detection. AI can identify skin lesion patterns such as irregular border, uneven color, and asymmetry. AI support doctor in diagnose but does not replace clinical judgment. I will pass next present to Aiman. Thank you.
Hi, my name is Mama Aiman bin Zulkifli, and I will continue with the differences between weak and strong AI. We start off with the scope. Weak AI is specialized in one task, while strong AI generalized across any task. This is because weak AI learn from specific training data for each task, where strong AI learn dynamically and adapt on the fly. For transfer learning, weak AI cannot apply knowledge to unrelated field, while strong AI could transfer knowledge from one to another. Additionally, strong AI is designed to mimic human intelligence, so it would have self-awareness and true understanding, while weak AI has no awareness or emotion, it's only mimic understanding. For example, in skin cancer detection, weak AI analyzes image for flat suspicion mole, but it cannot do anything. But as for today, strong AI is only theoretically and do not exist. Hence, weak AI is the main type of AI used in the medical field to support doctor in making decisions.
Hello, Assalamualaikum. My name is Muhammad Azkar Bashiri bin Muhammad Zaidi, and I will be explaining on my part, which is real world application. So, since my fellow friends have been talking about the definition of AI, we have been taught about evolution of AI in healthcare and also regarding the differences between weak and strong AI. Let me tell you the real world application, how we are using the AI in our future. So basically, it the AI actually helps in terms of early detection of skin cancer using computer vision. Alright, so AI can analyze images of moles, skin lesion, or unusual skin spots, which it helps classify whether the skin condition may be benign, suspicious, or potentially cancerous. So, to put it in words, AI doesn't replace doctors, okay, but it acts as a support tool to help doctors screen cases faster and more consistently. Alright? Alright, so here goes the problem part. Okay, real world problem. So, why skin cancer detection is difficult? Let me get you clear as crystal. So basically, skin cancer can be hard to detect early because cancerous spot may look similar to normal moles, as you can see in the example that I attached in the slides. Okay, so many patients ignore skin changes because there is no pain or discomfort. Okay, so this can cause late diagnosis and delayed treatment, which early detection is important because melanoma can spread quickly if not treated early. So it is a good invention to have AI in healthcare industry. Okay, now speaking of impacts of AI, or I could just say how AI helps in skin cancer detection, I include 4 points which strong enough to tell you that AI actually gave a big impact on healthcare. So first and foremost, the point is basically AI could faster the screening. Okay, so AI can process skin images quickly and highlight suspicious lesion. Okay, so which this helps doctor to identify which patient may need urgent examination. So that's the first point. So the second point is AI could be the support for doctors. Okay, so computer vision can act as a second opinion aside from doctor's opinion. So it supports dermatologists by detecting visual patterns that may be difficult to notice manually. And the third point is AI could help earlier detection, which in places with limited dermatologists, AI can support general clinics or healthcare workers. And it helps identify high risk cases earlier so patient can be referred to specialists more faster. And the last but not least, my fourth point is regarding the reduce the human error. So basically, doctors may face fatigue or heavy workload or different levels of experience. But AI can provide consistent image analysis based on the pattern learned from large data sets. So here are the four strong points that how AI could help in terms of skin cancer detection. Okay.
Hi and Assalamualaikum. My name is Zarul Hafiz bin Zainal Abidin. Next, I'm going to explain about knowledge representation model. Knowledge representation in artificial intelligence refers to the process of organizing information in a way that an AI system can understand, process, and use to make decisions. It is not just about storing data. It is about giving AI the ability to reason, the same way humans use knowledge to solve problems. There are a few techniques of knowledge representation that we can use in a structured form so that computers can process the data according to what we are thinking. For this project, we will use decision tree as our knowledge representation model. This decision tree representation model is about AI in healthcare, early detection of skin cancer using computer vision. The decision hierarchy evaluates criteria in order of diagnostic weight. Initial symmetry splits filter out genetic healthy tissue. If a lesion exhibits both asymmetry and jagged border profiles, the system runs deeper color analysis. When multiple shades are confirmed, it triggers an immediate urgent triage flag, ensuring high-risk cases bypass standard routing channels. Here are the details. Root node evaluation for the AI evaluates structural asymmetry. If the lesion is symmetric, it branches right to size evaluation. If asymmetric, it branches left to evaluate structural boundaries. Left branch if asymmetry is yes. The network check if the outer perimeter features jagged or irregular borders. If no, it is classified as a low-risk atypical mole or nevus, requiring an annual checkup? If yes, it proceeds to color variation analysis. Color check. If border irregularity is yes, the algorithm counts unique color pigment brown, black, blue, or white. If the lesion contains three or more distinct shades, it reaches the terminal lymph node. That means high risk. That require flag for urgent biopsy or melanoma protocol. If it contains fewer than three shaded, it is routed to a short-term clinical review track. Right branch if asymmetry is no. For symmetric lesions, the system evaluates the absolute physical size in diameter. If the diameter is greater than 6 mm, it is labeled borderline that need monitor via digital dermoscopy in 3 months. If the diameter is less than or equal to 6 mm, the leaf outcome is classified as benign or healthy tissue. That's all from us in AI in healthcare. Early detection of skin cancer using computer vision for our presentation project in AI in the real world. Thank you.